So in today's class, we are going to start the topic called as time series data. Till now, we have worked on the structured data. In the structured data means which is nothing but tabular data. So using the tabular data, we have worked with respect to machine learning. Complete machine learning is on structured data. And along with that, deep learning, the deep learning of ANN. These two, this part we have worked on the structured data. Coming to the next one is unstructured data. In the unstructured data, we are having two types. One is images, one is text. So images, we have worked using the CNN and along with the CV. Whereas text, we have worked using the NLP, that is NLTK package, NLP, right? So using the NLTK packages, and where within this text also we have seen the both supervised and unsupervised one, that is topic modeling, and along with that now Bayes theorem, that is supervised, right? Text classification, we have seen the text classification as supervised one, and along with the topic modeling as the unsupervised one, right? Now coming to this next type of data is time series data. Now in today's class, we are going to start the time series data. Now this time series data also we are going to use ML and along with the DL. So ML we are going to use ARMA, AR model, MA model, and ARIMA model, and SARI-MAX model. These are the various models which we are going to use in the ML. And in the DL, we are going to use RNN and LSTM. These both we are going to use in the time series data, right? These two algorithms. So let us start with respect to this time series, right? Now, coming to the, some of the students have asked me the questions that said this one or that one. And recently one of the batch, Linux batch is getting started, and some students are in, that is free. Linux is free course for the data science students, whether we have to join that one or not. These multiple questions, right? Now coming to the questions here, if you are a fresher, generally in the industry, what happens is, if you are a fresher, if you are hired as a freshers or 0 to 2 years of experience, okay, if you are having of 1 year, 10 months of experience also, you are considered as a starter or the basic in the starting level only of the data science. So up to 0 to 2 years, you are considered as the basic level or in the starting level. 2 to 4 years, you are called as mid-range. And more than 4 years only, you are called as experienced. Okay, so 2 to 4 years or 2 to 3 years or something. Some companies will take 2 to 3 years and more than 3 years as the experience. And with respect to like this, right? Now here, who are having with respect to 0 to 2 years of experience, generally they'll work only on the structured data. They'll work only on the structured data. Now, none of the company will give you images or related to computer vision or related to text, that is NLP. This part, whatever the artificial intelligence part is there, this artificial intelligence part will not be done by the 0 to 2 years experience people in the companies. Generally, in the 0 to 2 years of experience people, what they do is they'll work only on the structured data. That is either time series or with respect to classification or regression or collecting the data from the SQL, extracting the data. Major focus will go with respect to extracting the data and data pre-processing. That is the major part goes with these kind of people for 0 to 2 years. That is the reason I have focused more from the starting onwards with respect to machine learning algorithms, more number of machine learning algorithms, or we have dedicated more amount of time on the structured data. I have shown you with respect to the regression and classification algorithms, or with respect to data pre-processing, what are the different types of data pre-processing are there, or deployment part. I have focused more on this part. With respect to the, I have shown you the introduction part only with respect to image classifications or CV or NLP. This we have not that much of advanced level we have not done. Whereas this one we have done high advanced level, which is required in the real life. Now, 2 years or 2 to 3 years experience people, 2 to 3 years experience, whatever they are having, generally they will start working on this AI related projects, that is NLP. NLP they'll give for 2 to 3 years. For freshers, none of the company will give on the text data. Okay, because we require more accurate results. So NLP related projects means we'll get only from the high level companies. From high level companies, they'll have the budget, more amount of budget. When more amount of budget is there, then we'll go with the experienced people, not with the freshers or with respect to 0 to 2 years of experience. We can't take the risk in the companies, right? So that is the reason. So when you are having more than 3 years, now artificial intelligence part or CV part, everything will come. Along with that, cloud. Nowadays, earlier we used to work on the Hadoop and big data. Earlier, this is 3 years back story. 3 years back, we used to have the large amount of data. We used to store in the Hadoop, or we used to process that data in the Spark or something like this. But recently, the trend was completely changed towards everyone has moved towards the cloud. So the integrations with respect to the cloud, more things are cloud. So if you are having more than 3 years of experience, means one should be good at cloud. And 100% they have to be good at cloud. Okay, they have to work in the company or they have to shift to another company also. They should be good at one of the cloud technology, any one. So coming to the cloud, we are having with the most popular one is Azure, AWS and GCP. 3 things are there. One is Azure is by Microsoft, developed by Microsoft. AWS is by Amazon. And GCP, that is Google Cloud Platform, which is developed by Google. So we are having 3 different types of cloud technology. You can select as per your choice. And in the companies, sir, which is best? You can't ask that question because my company is working on the Azure. My earlier company, which I have worked earlier, it has worked on the AWS. So that company is having with respect to Microsoft related products. This company is having with respect to this one. Some companies will use MySQL as their database. Some companies will use SQL Server as their database. Which one is best, miss? Whether it is a SQL Server or MySQL database, finally you have to learn the commonly SQL only to extract the data. There will be small differences. Difference will be there. If there is no difference, then it is called as copyright issue, right? So there will be some kind of differences will be there. When compared to MySQL or SQL Server or Oracle, there will be light changes will be there. Similarly, here also there will be light changes, but main content will be the remains same. The ML data cleaning is not going to change. The modeling part is not going to change. The algorithms are not going to change. The hyperparameter tuning is not going to change. The hyperparameters is not going to change. Tuning is not going to change. Final model is not going to change. Pipeline is not going to change. Nothing is going to change. Only the deployment, the way of deployment and the way of selecting. Right? For example, if you are going with a Word document is there and Notepad is there. Both of them are used for writing the notes only, right? In the WordPad, you can write the notes, and the Word also you can write the notes. What is the difference then? Some advantages are there in the Microsoft Word. At the same time, some advantages are there in the Notepad, right? Based upon the requirement. For example, small amount of things, just I want to take one of the students' phone number. Then I'm going to open the Notepad and I'm going to write. I'm not open the Microsoft Word, right? Because it is going to take large amount of space. For that application, it requires some amount of space, right? So similarly, coming to the point, now, majorly we are going to focus on this structured data, how to extract the structured data from the database, how to present the data or how to work on the data. This is major part for us. As many of the students now turning towards, towards the end of the course, we are approaching towards the end of the course. We have to more focus on this part. If you are a 0 to 2 years of experience, if you are more than 2 years of experience, if you want to keep some kind of fake experience, then you have to learn additional things, right? In the starting, in the demo sessions itself, I have explained very clearly, this course is of 0 to 2 years of experience. If you want, you can check my demos videos, whatever the demo videos you are having, you can just open that. On the day 2 class or day 1 class, I have clearly mentioned that one. And the skill set required for the freshers and the skill set required for the experienced people also, I have kept separate slides in the PPT, and I have shown very clearly, right? So here my focus is for 0 to 2 years of experience, right? Now, for those people, you can work on the structured data. Within that structured data only, this time series also comes. Within the structured data only, this time series also part of the structured data. Time series is also part of your structured data. In the structured data, we are having two types. One is called as cross-sectional data. One is called as cross-sectional data. And one is called as time series data. Okay, one is called as cross-sectional data and one is called as time series data. What is meant by cross-sectional means if the data is independent to time. Data is independent. The data is independent or the problem is independent to time. There is no time dependency for the given problem to accept the loan or to reject the loan. Whether the penguins belongs to this category or that category. Mushrooms. These all examples, none of the example is having the time dependency. Whether the person is having a cancer or not. What is the says? There is no time dependency. In the given data set, if there is no time variable, then it is called as cross-sectional data. Till now, whatever we have discussed in the regression and in the classification and the ANN, that is Chen modeling, all of them comes under time cross-sectional data. Cross-sectional means there is no time variable. There is no column related to time. There is no time variable. And second, this time variable is not depending on your output variable, right? So your output is not getting dependent on the time. But whereas time series data means where your data is dependent on time. Like dependent on time. Example, like traffic at SR Nagar. Okay, traffic at SR Nagar. If you want to predict the traffic at SR Nagar, okay, SR Nagar Junction or Amirpet. Okay, traffic at Amirpet. If you want to identify or if you want to predict the traffic means the time is important. Okay, on holidays or if there is a public holiday or national holidays there, then there will be no much traffic. If it is a weekend, okay, or it is a Friday or with respect to some other days, okay, on Monday and Friday we'll have the huge traffic when compared to Tuesday, Wednesday or Thursday. And that too at the time of 7 p.m. the traffic will be different. At the same of 5 p.m. the traffic will be different. At afternoon 2 p.m. the traffic will be different. Here the time dependency is there. While predicting the traffic at Amirpet, the time dependency is there. Predicting the temperature, time dependency is there. Predicting the sales. For predicting the sales, that depends upon the given data. For example, if you work in the regression algorithm like a TV, radio, newspaper, in that they have not given the time series variable. For example, instead of TV, radio, newspaper, they have given me January sales. February says, March says, what are the sales are there? If they have given me the month instead of TV, radio, newspaper and says, for example, they have given me the month versus says. Okay, instead of this month, whatever the month you are having with respect to the month versus says. Then in this case, it is a time dependent. Day versus says. In this case, time dependent. So in some cases, time dependency is there. In some cases, time dependency is not there. How we can identify that one means first you have to take the data. First you have to collect the data. After collecting the data, first step is collect the data. After collecting the data, check whether there is a time variable is available or not. That is the first step. If the time variable is available, then you have to see whether this time, what are the time variable and the output variable, y, whether this both are having any kind of relation. How to identify means, for example, output variable is cancer. You have got the data set from some cancer hospital. From cancer hospital, you have got the data. Okay, patient records you are having, patient name and everything. And the patient admitted data also is there. What are the date he has admitted? One of the date column is there. And whether that particular patient is having cancer, yes or no. Cancer, you are having the output variable called as cancer, yes or no. Now, if you collect the data from your database, you are having with the date column. Date column is there, name column is there, age column is there. Like this you are having with respect to, and their reports, whatever the reports they're having, the reports values. Now using all these things, we are having the data set. Now first step is to check whether time series variable is available or not. This is my first step. Time series variable is available or not. This is my first step. Yes, in my case, time series is available. Now, first what I have to do, if it is available, if it is not available means then it is called as cross-sectional data. Blindly it is called as cross-sectional data. No discussion on that. If it is available, again, two questions. Now, whether this time is having any relation with your output or not. Means if the patient was admitted on the March 1st, he will have the cancer. If he is admitted on March 15th, he is having no cancer. Is there any rule like that? Just we have to apply our common sense. Is there any connection between the date versus whether the person will have the cancer or not? So there is, with respect to, this is not admission date, the person visited date. Admission date means why the people will admit they'll have cancer only, they will admit. So we are having visited date. Okay. So now here the visited date versus cancer, is there any relation? So we'll identify that there is no relation between the visited date to the hospital to the cancer. So once we are identified that there is no relation, means just simply we'll drop this column. For example, we have identified there is a relation. Then we have to process according to that. Is that clear? This analysis means working on the time series data. Okay. Now, here, what are the time series data we are having? So here, we are going to cover the components. What are the various components of time series? Second, we are going to see whether there is a time series is stationary or not. If the time series is stationary only, we can build the machine learning model. For example, how we have done the data pre-processing for regression and classification algorithms. For regression and classification algorithms, first we have to see if there is a missing values or not. And we have to check whether there is a text data or not. If there is a missing values means you have to clean the missing values. If there is a text data means you have to do the encoding. Otherwise, what happens if there is a missing values and you have given directly the missing values to your classification algorithm? It will throw the error that some of the data is missing and we can't fit the data. It will throw the error. For example, text data is there. You have not encoded. You have not done the one-hot encoding, or you have not done the ordinal encoding. Without doing the encoding, directly have given to the model and you have fitted. Then what it will throw? It will throw the error that this data consists of some text data where the model is unable to understand. So it is going to throw some kind of error, value error. When you are passing this text data, it will throw the value error. When you are sending these missing values, again, it will throw the same value error. The values are missing. Now, for classification or regression algorithms, we have to clean the missing values and the data has to be encoded. Similarly, for the time series data, data pre-processing includes with respect to stationarity. The data should be stationary. Otherwise, we have to convert it to the stationary. Okay, if the time series data is not stationary, means we have to convert it. How to convert? Everything we are going to see step by step. First, we'll understand what is the components of time series, what are the different time series are available, and what is meant by stationarity. If the given data is not stationary, how to convert to stationary, and next, how to apply the ARIMA model, and how to build this using the Python. What is meant by ARIMA model and how to build. Now, let us start with respect to the time series data. Now, the data was collected based on the intervals of time, different intervals of time, the data was collected. Then it is called as time series data. And for this time series data representation, we are going to always use the line plot only. The time series data will be always represented, always. Always it will be represented using line plot only. On the x-axis, you have to take time. The time might be date, day, week, month, anything, but it should be related to time series. Hours, seconds, minutes, everything, anything you can have, but on the x-axis, you have to take the time. As the time changes, how that particular data is changing. The value of the value should be on the y-axis. Okay. Now let us take an example. Let us take an example like real life example where we are having the sales of Flipkart turnover. Whatever the Flipkart we are having, Flipkart turnover on the January month. This is the value turnover. This much of turnover they have made in the January month. In the February month, this is the turnover. In the March, they have made certain turnover. In the April, in the May, and in the month of June, in the month of July, in the month of August. You are having something like this. Okay, a graph something like this. Right? So these are the sales. Now what you are going to observe means from this line plot, we are going to analyze the data. Descriptive analytics we are going to do, at the same time predictive analytics. Descriptive analytics means when in that out of all of them, May month is having the least sales. Okay, in the given data, the May month is having the least sales because there is no offers on the May month. There is no festival, nothing will be there. So if there is no offers or nothing, new sales are there, everyone will wait for the upcoming sales. During the sales, some kind of offer days, they'll purchase that one, right? Now in the month of January, at least we'll have some kind of New Year sales or with respect to Republic Day sales. Pongal sales will be only in Andhra, Tamil Nadu will have this one. Okay. Whereas with respect to Flipkart or Amazon, it will see overall India wise, not with respect to individual state wise. So in the January month, we are having with respect to the New Year sale and along with the Republic Day sales. Two options we are having. And in the month of February, the sales will be dropped comparatively because here there is no much things are there. Only one and only we are having is Mahashivratri. Right? So in this, they are going to have some kind of offers. And in the March month, year ending sales, financial year ending closing, that year will the financial year ending closing. So generally they will clearance sale. They'll have some kind of clearance sale. They'll try to clear that whatever they are having in the month of March. So that overall annual turnover they want to increase in the month of March. So that again they'll give some kind of sales opportunity. And coming to the April, the sales will be comparatively low. Again in the month of May, it will be drastically very low. Again in the June, some sales. There will be some kind of festivals, and in the July and in the August. From August to December, the sales will be in the increasing order on. Right? In the September month, we are having Ganesh Chaturthi, and in the October month, we are having Big Billion Day sales, which is one of the biggest one. And in the November month, we are having Diwali sales. And in the December month, again, Christmas sales. So just observing this one is called as descriptive analytics. So here I'm going to collect the turnover of sales. Whatever the sales was done, the turnover, I'm going to calculate for every month. Month-wise. Regular interval is month-wise. Every month, I'm going to take the value of turnover, whatever the turnover is there. So, I'm having with respect to monthly turnover or with respect to monthly sales, whatever you are having. So, the time series is defined as the set of measurements of certain variable. Certain variable means sales variable at a regular intervals of time. Means you are having month column and the turnover column. These are the two columns which you are having. On x-axis, you are going to take different months. On y-axis, you are going to take the sales. Here, the time acts as your independent variable. The x is your time. Y is this output variable. X is your time. Time variable is your x. Okay. Here, the data pre-processing and everything is in a different way. Completely, we are going to do in a different way. The time series, whatever the time series or the time is given at T1, T2, T3, the value of Y1, Y2, Y3 means each record. We are going to have each record like this, and where the output is function of f of t. Earlier the function is f of x. Y is equal to f of x in the normal cross-sectional data. For time series data, y is equal to f of t. Means your output variable is completely dependent on the time series variable. Right? Now, so applications are with respect to daily sales, weekly sales, production, manufacturing. Manufacturing company majorly use all the manufacturing companies 100% they'll have this one. Manufacturing companies, e-commerce companies, 100% they'll work on the time series, right? And for calculating the year's GDP and to calculate with respect to the inflation rate, all these are with respect to the time series and monthly tickets, like any airways related companies like Indigo or SpiceJet or whatever the companies we are having with respect to Air India or all these companies, they are having with respect to tickets, how much tickets they have sold. And based on that, they are going to analyze and they are going to predict. And based on that, they are going to have with respect to number of flights, right? Now, here, the time series, in the time series, we are having different components, out of which the first component is called as trend component. That is the first component. Now, based on the observation of your line plot, we have to identify the trend, whether it is in the uptrend or whether it is in the downtrend. So, for example, if you observe here, this graph, ups and downs are there. But every ups and downs, finally, if you check this ups and downs and everything, finally you can see that it is slightly increasing only. Though it is increasing and decreasing also, slightly it is increasing. Finally, it is in the uptrend. Trend is in up. So this is called as uptrend. Okay. So just you can identify from your time series data, there is with respect to what is the trend. How to calculate the trend means just whatever the lower values are there, attach them. Attach all the lower values like this, one by one. Wherever the lower values are there, attach the lower values one by one and draw a line. Just if the line is in the like this, increasing, then you can understand. For example, if you see here the lower values, whatever the lower values are there, I'm attaching all the lower values. From the lower values, I can say this is in the downtrend. So this is the example of downtrend and this is the example of in the uptrend. Right? In between, ups and downs are there. Everywhere ups and downs are there. For example, let us take like this. Initial value is this one. First it increased, decreased, increased, decreased, increased, decreased, increased, decreased. Finally, it is from here to here. What happened finally? Increased or decreased? Overall. Overall, it has increased. Multiple times it has fallen and up and downs are there. But from whatever the starting point you have collected, whatever the ending point you are having, from here to here, finally it has increased only. So this is called as uptrend. From the starting point to ending point, if it is end, this is the starting point and this is in the ending point. Now, if you observe this one, this is in the neutral trend for this given data, or it is in the decreasing order, right? The value was decreased and that too, from here to here, it is increased. Suddenly from here to here, it has started decreasing. This part is called as uptrend part and this part is called as downtrend part. Okay, just we can observe the trend based on the line plot. Oh, others are unmute. Huh? Just a minute. Now it is clear. Background is clear now. Yes. Done. So we are having some kind of uptrend and downtrend. Trend is the first component. Trend is the first component of the time series. Right? Now, second component. What is the second component we are having is seasonal. Seasonal means for every season, the pattern gets repeated. For example, if you observe the Flipkart says every time, again in the month of October, November, December, the sales will be very high. That particular quarter, the sales will be very high. Every year, that particular quarter will be very high. The same pattern is getting repeated. Okay, then it is called as seasonal. In a particular season, it is getting repeated. So here, if you observe this one, when factors such as time of the year or day or week affect the dependent variable, respective patterns are observed in the time series. You can observe the pattern. Every time you can observe there is a one pattern. This is again peak, again peak, again peak. Means after 2 times, again one peak is there. After 2 times, again one peak is there. You are observing that one, which is called as seasonality, right? That is called as seasonality. Seasonality or seasonal, which is the one of the component of time series. The third one is called as cyclic. Cyclic means up and downs. The patterns, cyclic patterns, like similar kind of seasonal patterns, we are having the cyclic patterns. It will exhibit both rise and fall. Sometimes up, sometimes down, sometimes up, sometimes down, sometimes up, sometimes down. This is called as sideways. This is called as sideways. Sideways means one time it will go up, one time it will go down, one time it will go up, one time it will go down. There is no proper trend is in there, right? This type of pattern is there means this is very difficult to analyze. For example, there is an uptrend is there means we can identify the next step. Okay, next it is going to slightly increase, but how much percentage of increase we are going to predict, right? If it is in the downtrend means we can clearly identify that it is going to decrease. How much it is going to decrease furtherly, right? If it is in the side trend, then it is very difficult to analyze, right? If the market is moving, for example, any stock or any particular values are moving with respect to continuously after a certain period of time, it is slightly increasing means it is considered as in the uptrend. And we can predict. For example, let us take like Reliance. Okay, Reliance is the company, and this in the share market, if you take the Reliance share value, if it is having some kind of trends like this, whatever the graph we are having, the Reliance graph will be something like this. But finally, the trend is in the upward direction. From here to here, it is in the upward direction. Might be sometimes up and downs will be there, but finally it is having with respect to uptrend. So from this also we can clearly project that in the 2023 the Reliance share is going to increase 100% blindly. Okay, based on the whatever the pattern we are observed till now from the last 10 years data, based on 10 years data we can clearly predict that just by descriptive analytics only, just by saying the line plot itself, we can say that in 2023, the Reliance value is going to increase 100%. But how much percent it is going to increase? Whether 2% or 3% or 5% or 10% or 20%. For example, Reliance share value is as of now, assume, I don't know exact value. Assume it is 2000 approximately. Reliance share value is approximately 2000. Exact value, I don't know. Right? Now, if it is approximately 2000 rupees are there. Now I am investing approximately 2 lakhs rupees in this Reliance. Means I am going to get 100 shares. 100 shares of Reliance. I am going to buy the 100 shares of Reliance at 2000 rupees by investing 2 lakh rupees. Okay, I have invested. Now, at what time I have to book the profit? After from 2000 to 2010, it has got with respect 10 rupees profit. 10 rupees into 100 means with respect to 1000 rupees as the profit. Should I book my profit for 1000 rupees? Or should I wait for 2020? Not year, value. Okay. Should I wait for up to 2020 or 2030 or 2040 or 2100, 2100 or 2200? Till what I have to wait? This is predictive analytics. But increasing, 100% is increasing. That is clear. That is called as trend. That is the difference between both of them. From the line plot, we are going to describe the data. From the predictive analytics, we are going to predict the data. Is that clear? Now, here, this is called as cyclic pattern. Next, we are having called as irregular pattern. There will be no pattern in this. Completely ups and downs, like Adani. When it will go, when it will increase, when it will fall, they only don't know. Okay. Suddenly, from the year of 2015 to 2018, it has increased slightly. But from 2018 to, sorry, not even 2018, 2019 also. Okay, 2019, 2020 also. But from suddenly 2019 to 2022, Adani from 42 position to directly world third vice position. Now, in the year of 2023, due to one report, right? Whatever the Hindenburg report is there, based on one report, completely it has been collapsed, right? And it is having complete irregular pattern. There is none of them can forecast Adani. Blindly we have to fix that. Okay, till the Modi is there, we have to fix the Adani. Once the Modi get down, means Adani will fall. Everyone knows this one. Very clearly, everyone knows. Till the Modi there, we can go. So in the year of next year 2024 elections, everyone are predicting Modi only. Once again, because there is no opponent also for Modi. Sorry, everyone are resuming Modi. So still they are investing in the Adani. For example, some strong opposition has come into picture. Suddenly Adani prices will fall. Here there is no business, not based on the business. Completely, it is a manipulating game, which is called as irregular patterns. For this irregular patterns, none of them use the predictive analytics. You can't predict. You can't say that, sir, if I invest in Adani, what happens, sir? That will not be decided based on the chart. That will be based on the luck. That will be decided based on the luck. For example, tomorrow, if some other news from we get some kind of other news from Boston University. Okay. So they will also release some kind of news like this. Some others like Citibank, they are going to degrade that Adani Enterprises. Suddenly the values will fall. So that is not purely based on the business. That is purely luck on the luck. Okay. Today you may get a news, positive news on Adani today night. Tomorrow morning you may get bad news also. Anything can happen. Right? But whereas Reliance is not like that. Whereas with respect to SBI, it is not like that. Whereas with respect to Bajaj, it is not like that. Right? So these are having with respect to high fundamentals. High fundamentals are there, and the pattern also you can identify very clearly, and based on that you can have the investments also. The mutual funds investor, but don't ask me, sir, that we are going to predict the stock market and the share value. If we can predict the share value more accurately, if I can do that one, then I'll be not in the narration. Right? That is very simple answer. If I can do that one, every day I will invest some money and I will take profit. Again, I will invest. Again, I will take the profit. If I can predict more accurately that one. None of them can predict the markets with respect to using the machine learning, because the markets are based on the news, everyday's news, based on the political news and based on the outside, whatever the things are happening. Right? Suddenly, tomorrow, one of the person name is XYZ. He has taken some kind of 10,000 crores from SBI. Now, he has suddenly escaped. SBI values will fall. Completely it will fall. What is there in the pattern is not there. There is no with respect to charts. There is nothing with respect to called as prediction, modeling, nothing. Model can't predict the news, right? Model can predict based on the chart. It can assume the next step what happens based on the chart only, assuming that data is stationary. It is not going to fluctuate based on the news, right? So it is somewhat difficult to predict the stock markets using the machine learning or data science concepts. For that, we are having a different concept. Completely, that is a different one that we'll discuss later in the end. Okay, if you are interested. That is not here, right? But this, whatever the data we are having, this type of time series data in the real time, apart from the stock market, where we are going to use like sales prediction. All the manufacturing companies, they will use with respect to how much they have to manufacture. For example, Maruti is there. How many Maruti cars has to be manufactured in the month of February? It is already predicted. Based on that prediction only, they are going to do the manufacturing. For example, they are forecasting in the month of February, approximately 1,000 cars they are going to sell. Example, they are going to sell the 1,000 cars. For example, they have manufactured 1,500 cars or 1,100 cars. Now, what happens to remaining 100 cars? That gets into the investment and it will be sold in the next month. That is okay. But initially, you are going to have the more investment. So with less investment, we have to get more profits. Means we have to predict properly. We have to estimate the data properly. So all the manufacturing companies will do this one, time series, like Flipkart, Amazon, all the e-commerce companies everywhere, right? Now, what are the data we are having? So some kind of noise, irregular patterns are also called as noise. Okay, all the irregular patterns, whatever you are having, this irregular patterns is also considered as noise. Now, What is noise? So when we are having with respect to noise or irregular patterns are available, then we can't do the time series. The data should be removed the noise. We have to remove the noise and means the data should be stationary. Okay. The data should be stationary. Then only we can apply the time series variable. What is meant by stationary? Stationary means constant mean. The up and downs, whatever the things are there, we are having with respect to the constant mean, the mean value. If you calculate this value and this value, this is the average value. For this one and this one, this is the average. For this one and this one, this is the average. If you take the average values of up and downs, if you take the average values, if this average value is constant, then it is called as stationary. The data which is having a constant mean, the data which is having a constant variance is called as stationary data. Consistency is there. Up and downs we can predict easily. Okay, whichever the data is having the stationarity, that predictions are easy, right? If there is no up and downs, I mean, there is no stationarity, then it is very difficult to apply the model. Now, stationarity means the data, time series data. If the data has constant mean and constant variance, if the constant mean and constant variance are there. What is constant mean and constant variance? For example, from here to year of 2000 to 2004, I'm going to consider up to 2004, means 4 years of data. For this 4 years of data, if I calculate the mean value, some mean value and variance value, from 2004 to 2008 also, I'm having with respect to the change in the mean is same. The mean, whatever the difference in the mean is there, the mean difference is same and the variance also almost same. The variations, whatever the variations are there, that is constant, right? Now, if there is an uptrend, there is a trend, or if there is a some kind of, if you observe here, from here to here, if you calculate the mean value, from here to here, if you calculate the mean value, from here to here, if you calculate the mean value, they are different. If you calculate the mean value from here to here, you'll get some mean. From here to here, the different mean. Mean is here in this case, the mean is increasing. It is not constant. It is increasing continuously. In this case, the mean is again, once again from here to here. If you consider from here to here, one mean, and from here to here, you are having a different mean. And from here to here, you are having a different mean. So here we are having with respect non-constant mean or non-constant variance. Then it is called as non-stationary series. Now, any data which is non-stationary has to be converted to stationary. That has to be converted to stationary. How we are going to convert to stationary? So before converting to stationary, first we have to check whether the given data is stationary or not. How to check whether the given data is stationary or not means we are having two options. One of the option is called as rolling statistics and one of them is called as Dickey-Flurer test. This is also called as ADF. Okay, ADF test. Right? Dickey-Flurer test. Right? Augmented. A stands for augmented. A stands for augmented Dickey-Flurer test. ADF test means augmented Dickey-Flurer test. We are having, this is called as hypothesis test and this is with respect to rolling statistics. Two options we are having. Using these two options, we are going to check whether the given data is stationary or not. So let us see that one. I will do the simultaneously the coding also along with this. I'm going to import NumPy, Pandas, Matplotlib, and Seaborn, and warnings. Everyone knows all these particular libraries. And just I'm going to load the data set called as air passengers data. Now, if you observe this air passengers data, I'm having with a data set from 1949. Okay, 1949 to what is the ending data miss? Let us type only the data. So from 1949 to 1960, total 12 years of data. From 1949, that is 1949, 1950, 51, 52, 53, like this, so on up to 60. So this part is 10 years plus this part is 2 years. Total 12 years of data we are having, that too monthly wise. So if you take this one, every month 15th, they have collected the data. So January month, February month, March month, April and May. So month wise I'm having. Total 12 years of data, 12 into 12 months, total 144 records I'm having here. So this data set consists of 144 records, out of which we are having one is month and one is passengers. So here, this is our X variable. X variable is our time. This is our time and this is output variable. Now, based on this, we have to predict on the 1961 or with respect to January 1961, what would be the expected number of passengers, or with respect to 1961 February, March, all these things we have to predict, right? And we have to apply the modeling for this given data. Now, how we are going to do that one means, I'm going to set this month, whatever the month column is there, that I'm going to use as the set index. So this is going to be in the index column. I'm going to convert to this index column, and I'm going to take only the output variable called as Y. I'm having now only one column. Now X column I have set it to index. Now, whatever the data I'm having, just first I'm going to apply the line plot. On the line plot and the x-axis, I'm going to take the data dot index. Index means what index? These are the index values. Month you are going to take on the x-axis, and passengers, df of data of passengers means this column. This column you are going to consider on the y-axis, and you are going to apply the line plot. So I have got the line plot. From this line plot, can you tell me whether it is a stationary data or non-stationary data? Before moving to stationary or non-stationary, tell me what are the components you have observed. Is there any trend in this? Yes, uptrend. Uptrend is visible. That is clear. Second one, is there any seasonality in this? After a certain time, any season you can observe this particular things, right? Every time after a certain period of time, from here, suddenly it is getting huge spike from this point, from this point, from this point, every time. In every year, one season, spike is there. One spike is there, right? So here, this is also having the seasonality. So uptrend is there and seasonality is there. Now, whether it comes under time stationary data or non-stationary data, means it comes under non-stationary. By saying itself, we can conclude this one. But instead of by saying, just we'll apply some type of line plots will be there. That by saying we can't identify correctly, exactly. Here in this case, it is very clear. Based on the line plot itself, we can identify whether it is a stationary data or non-stationary data. But some data will be there where we can't identify properly. Now, in this case, what we are going to do? In that case, check for stationarity. What we are going to do is, for every 12 records, I'm going to take the every 12 rolling means every 12 records. First 12, after that 12, after that 12, after that 12, after that 12. 12 records. Every time you consider the 12 records, and for that 12 records, you calculate the mean. For every 12 records, you have to calculate the mean. So what it is going to do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13th record is there, right? This 13th record is going to take the previous 12 records average. 14th record is going to take from 2 to 13 average. 15th record is going to take from 3 to 15 average. Like this, the previous 12 records it is going to consider. For this 11th record, for 11th record, the previously 12 records are not available, right? So it is not going to calculate. So from where it is going to calculate? From the 13th record only it is going to calculate. The previous 12 records average it is going to consider. Why I am considering the previous 12? Because in a year I am having 12 months. So 12 I am going to consider. Using the 12 records, I am going to calculate the mean. For these 12 months, I am going to calculate the standard deviation. Now what I am going to do? I am going to use plt.plot. What is meant by plt.plot? Line plot. I am going to use the line plot for the original data, and color is equal to blue. This is called as original data. plt.plot mean. What are the mean values I have got? For every value I have got the means like this, right? The means. And similarly, plt.plot of standard deviation. By using these three, I'm going to keep everything in the one particular cell only. Now you can clearly observe this one. So can you see here? First 1 to 12 records, it is not having any rolling mean. Started from the 13th record only. From the 13th record, whatever the 13th record is there, this 13th rolling mean value is calculated by considering the previous 12 values. 14th record rolling mean is calculated based on the previous 12 values. 15th record rolling mean is calculated based on the previous 12 values. Like this, it is going to calculate for previous 12 values, it is going to take and it is going to calculate. Now you can see whether this mean is increasing or decreasing. Increasing. The mean is continuously increasing. So this is called as uptrend. From using the rolling statistics, we can easily identify the trend. Right? Whereas coming to the standard deviations, this is the black line. I have taken the black line as the standard deviation. Okay. Standard deviations I'm going to represent using the black line. Similarly, how you have calculated the rolling mean? Example. Some of the students, it might be different because first time you are listening, right? So rolling mean. Once again, I'm explaining what is meant by rolling mean. First, record 1, record 2, record 3, 4, 5, 6, 7, 8. 8 records are there. Take some values as per your choice. 100, 104, 109, 99, 24, 109, 100, 108, something you are having. Now what I'm going to take is rolling mean of 2. Rolling mean of 2. Now, first record, previous 2 records it has to consider. Is there any previous records to this? No. This is original data. This is original. Rolling mean. I'm going to create a new column called as rolling mean. Rolling mean of previous 2 records, it has to take the mean. Here, any previous 2 records are there? No. For this, previous 2 records are there? No. 1 record only is there. Previous to this, only 1 record is there. No. 109. Previous 2 records means these 2 are available. So these 2 average. What is the 2 average? 102, 100 and 104. What is the average of 100 plus 104 divided by 2? What is the value? Nothing but 102. Next, it is going to take the average of these 2. Next, average of these 2. Average of these 2. Average of these 2. Average of these 2. For every 2 records, it is going to take the average. First 2 records only will not have the values. Remaining all the records will have the average. So like this, you are going to calculate. First, this is the rolling mean. Next, here, for this, what are the previous 2 records? That is 104 plus 109 divided by 2. For this, what is the previous 2 records? 109 plus 99 divided by 2. For this, what is the previous 2? 99 plus 124 by 2. For this, previous 2 records are 124 plus 109 by 2. For this, 109 plus 100 divided by 2. This is called as rolling mean of 2. If you are considering rolling mean of 3 records. Rolling mean of 4 records. Rolling mean of 5 records. Right? Previous 5 records, average and the present value. So this is the present value. For this stage, this is the present value. Average of these is this one. This is the present value. This is the average value. This is the present value. This is the average value. Present value, average value. Present value, average value. Right? Now you can see here rolling mean. Now the rolling mean is in the increasing order. The mean is increasing. The mean is not constant. If the mean is like this, you have got a straight line like this, then it is called as constant mean. If the mean line is straight line, then it is called as constant mean. If the mean is increasing, then it is not called as constant mean. Right? Second option we are having is ADF test. This ADF test has null hypothesis says that the given time series is not stationary. Okay. The given time series is non-stationary. So this is the null hypothesis for the ADF test. For the ADF test, the null hypothesis is time series is not stationary. Now from the stats model.tsa.stat tools, I'm going to take the ADF test. And this ADF test, whatever the ADF test I have imported, this ADF test I'm going to apply on the passengers data. That is DF of passengers column. This particular column, I'm going to apply this ADF test. And once I applied this test, now I'm going to get within this multiple values I'm going to get. If I see the help file, in this, it is going to return me. What it is going to return me is, first one is test statistic value. The second value is P value. So hypothesis test, whatever we have done is everything on the based on the P values only. If the P high, null fly. P low, null go. So in this case, what is the P value is 0.099 is the P value. P is greater than alpha or P is less than alpha? Alpha is 5%, fix. Okay. So now 5% of significance, that is whatever the P value I have got is 0.99, alpha is 0.05. P is greater than alpha. P is greater than alpha means P high, null fly. Means accept the null hypothesis. What is your null hypothesis means? Null hypothesis is time series is whatever the given data is non-stationary. It is a non-stationary. By using the ADF test also you can calculate the same thing, or by using the rolling statistics also you can conclude the same thing. Either by using the rolling statistics or by using with respect to ADF test. We are going to conclude whether the given data is stationary or not. Now, next, how to convert this non-stationary data to stationary? Removal of non-stationarity, how we can do? We are having two options. Option number one is called as differencing and option number two is called as decomposition. Option number one is called as differencing. Using the differencing, we can remove the stationarity. Okay. Now, what is meant by differencing? Let us understand. Decomposition means nothing but regression. Okay. So here, whatever the differencing we are having, the differencing is observed based on the previous observations. Whereas decomposition is your regression technique only. There's nothing but beta naught plus beta 1 into t plus error. So decomposition is similar to your regression. Just differencing is the previous record. It is going to difference the previous record. So now let us take another example. 104, 102, 109 or something like here only I'll show you. Okay. So this is the data set where first 5 records I'm having and last 5 records it is printing, right? Now here, if you take, I'm applying the data dot head function of 10. 10 means first 10 records it is going to display. Right? Now, what I'm going to do is differencing. Differencing means with respect to y t minus y t minus 1. Means, for example, if you are considering this one as your yt, to this, the previous value you have to remove. Okay. Now, for this 118 minus 112, which is nothing but 6. This is 132 minus 118, which is nothing but 14. 129 minus 132, which is nothing but minus 3. 121 minus 129, which is minus 7. This is called as differencing with respect to 1. This is differencing with respect to 1. Right? So you can do the differencing with respect to 1. So how we can do that one? Let me show you how you can apply the differencing miss. So here, differencing is nothing but your NP data of passengers. What are the data of passengers you are having? Dot values minus TS this I am storing in the TS variable called as TS, and this is nothing but difference is equal to TS minus TS dot shift of 2 or shift of 1. Let us take shift of 1, right? Can you see here now? Shift of 1, the whatever that we are having here, the passengers data, passengers minus the previous one, that is nothing but, can you see this 118 minus 112, next 132 minus 118. The first one, the first difference is null, because for the first one, the previous value it has to remove. There is no previous value is available. So the first one is considered as null. The first one is considered as none. Second one is considered as 118 minus 112, which is nothing but 6. 132 minus 118, which is nothing but 14. Next, 129 minus 132, which is nothing but minus 3. So just if you observe here, 6, 14, minus 3. Is that clear? Previous one. To the previous one, we have to remove. That is shift. The previous one, how many previous steps you have to remove? The previous one to previous one you want to remove. The previous one to previous one you want to remove. What is the shift you want to apply? That shift. If you are applying one miss, the previous one only it will be selected. Okay. The previous one, for example, yesterday. Yesterday means only yesterday. Day before yesterday. Yesterday to 1 day before to that. Like this. Similar way here also, the shift of 1 means only the previous one will be considered. Shift of 2 means 2 differences it is going to take. With respect to 130, this one, whatever the 132 is there, 132 minus shift of 2 means than this one to this one, that is 112. It is going to select this one. Now 129 minus shift of 2, not this one. This one it has to correct. 121 minus not this one it has to collect, which is 132. This is shift of 2. If this is shift of 2, where we are having with respect to, if you go with the shift of 2, you will have with respect to first one is, first 2 records will have the none. And the third, next 132 minus the first record, third record minus first record. That is, this one is 20. And this is with respect to 11. And this is with respect to minus 11. Is that clear? Shift. This is one way. Now here, whatever the new data you have got, for this new data, shift of 1. First, you are going to try with respect to shift of 1. And you are going to get this data. This is the new data. Right? Now, in this new data, just apply. Apply the concept of whether it is a stationary or not. Just check. Check whether it is a stationary or not. Next, try with shift of 2. Check whether it is stationary or not. Like this, you try with the shift of 3, shift of 4, shift of 5. Wherever you are going to get with respect to the stationary, that you have to identify. Is that clear? Just by differencing to the previous values, we are going to generate the new data. And for this new data, again, we are going to check whether this given data is stationary or not. Is that clear? This is one way of doing the stationarity, converting the data to stationary data. Done? Now, here, what I am going to do is, for this data set, why there are 2 NS? Very simple. 2 NS, why you are having 2 NS? Because, for example, for this 112, the previous to previous, can you get previous to previous? No, that is not possible. NAN. For 118, previous to previous, this value is not available. So NAN. 132 minus previous to previous, yes. 112 is available. So it started from 23rd one. Right? Now, for example, shift of 3 is there. Now, what is meant by shift of 3? What are the shift of 3? That is this one, 1, 2, 3. Previous to previous to previous, not available. For this one, previous to previous to previous, this one, no, not available. For this one, previous, 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 no, not available. 3 times you are going to get none. None, none, none. What are the shift is there? That none values you are going to get. Now 129 minus which value you are going to subtract? 132 or 118 or 112? Which value? 112 value you are going to subtract. And you are going to get 17. For 121, what value you are going to subtract? If shift of 3 is there? That is not this one or not this one. 118. Which is nothing but 3 you are going to get. Right? Next, 135 minus, or what is the value you are going to subtract? With respect to 132, which is nothing but you are going to get again 3. For 148, what you are going to subtract? 129. and you are going to get the value which is 19. Like this, you are going to get. This is shift of 3. If you apply the shift of 3, you will get 3 nuns, 17, 3, 3, something like this. Just apply the shift of 3. 3 nuns, 17, 3, 3, 19. Is that clear? Just it is going to remove the previous to previous to previous value. 3 steps backward. Okay. Is that clear, guys? Online students? Shift, that is differencing. Right? Sunil, is your question is clear? So finally, you are going to do using the differencing, and you are going to calculate and you are going to make the time series as stationary before processing the data. Before moving to further step, first we have to do the data should be time series, should be stationary. So here, what I'm going to do is I'm going to apply the log transformation. Okay. And after applying the log for each and everything, now I'm going to do the shift of 2. Shift of 2 means previous to previous. First, I tried with 1. Okay. First, I tried with 1. And using the 1, I'm dropping. So shift of 1, whatever the data I have got, first value, I'm going to get some value. This value, I'm going to drop. Because to apply the ADF test or rolling mean, missing value should not be there. So the missing values, what are the missing values are there? That missing values I'm just dropping. And now I'm just applying the rolling statistics once again. Now, whatever the, can you see here? Almost constant mean, almost, but not exactly. Just I'm applying the ADF test also. Now from the ADF test, I got the p-value is 0.07. What are the p-values there? P is equal to 0.07, which is alpha is equal to 0.05. P is greater than alpha. P high, null fly. Null means again that given data is not a stationary. Then what I'm going to do? Shift of 1 I have tried. It is not working. Now what I'm going to do is I'm going to apply the shift of 2. I'm moving to the backward. Here I'm going to write instead of this shift of 2. Okay. Now again I'm going to check with respect to. Now this time, whatever the ADF test, I have got 0.02. P-value is less than alpha. Now the given data is stationary. This data is stationary. Where this is the rolling mean and this is the rolling standard deviation. Almost constant. Constant mean and constant variance. Is that clear? In this way, you can do the data to stationary. Any data to convert to stationary, just you are going to apply the differencing. Right? Is that clear, guys? Now, once you are doing the differencing, next, what is the next step means? You are going to apply the models. What are the models we are having means? Models are, first model is AR model, which is called as auto-regressive. The second model is called as moving average. And the third model is called as combination of these two, which is nothing but ARMA model. Auto-regressive moving average. AR and MA, ARMA. And for that we are having, this is the old one. Now the latest one we are having is ARIMA, which is nothing but auto-regressive integrated moving averages. Means they have combined everything. They combined everything and they have created the model called as ARIMA model. Now let us start with what is AR model. First, let us start with AR model. Auto-regressive. Auto-regressive. Now what is meant by auto-regressive? Regressive means nothing but regression. It is going to do the regression of the previous values. So is I'm going to take some data X. Okay. Now I'm going to give 1, after that 2, after that 3, after that 4. Now if I'm using these 4 values and if I'm dragging like this, it is printing the next values. Everyone knows this one in the sequential order, it is selecting. Okay, fine. Just I'm going to select this one as 11, 14, 17. Now what it is going to do? It is going to identify the relation between these 3 of them. Is there any relation? Just it is applying the regression algorithm. Is there any relation between one to another one? So for this one to this one, what is the relation, and from here to here, what is the relation. Just it is applying the regression concept, and using this, it is going to predict the next value, the differencing value. Now, here, instead of, there is a sequential pattern, just x plus 3, whatever the values are there, x plus 3. For example, I'm going to take 1, 4, 9, 16, 25. That is squares, everyone knows, right? Now, using this one, just I'm applying this one, the logic. Now it is showing for me 29. Using all the 4 values, just these 4 values I'm going to apply. And I'm applying like this means it is going to give me 29, not 36. Actually, it has to give the 36. And after that, 49. If I continue this same thing, first 5 values, if I select and if I continue means, it has to give me the 20, 36, 49. And after that, 64. After that, with respect to 81 and 100, it has to print in this way, but it is not printing in that way. It is printing in this way. Just it is adding with respect to, first it has added the 4, for this 4 it has added, after that 5 it has added, after that 6 it has added, from here to here also 6 only, from here to here also it is adding 6 only. Now why it is adding only 6 or with respect to 5 or 4? Because by default, it is going to apply the linear regression. If it is applying the polynomial regression means y is equal to x square, it is used to identify. But it is not able to identify the relation between y is equal to x square. It is because the model, the Excel sheet was created by selecting the linear regression, the identifying the relation between them just in a linear way. Means the next value, it is going to select based on the previous value with 4. So here it has given me the perfect relation. Just I have selected these 4 values, next value, it has predicted properly. But in this case, it is not able to predict properly because it is applying the linear regression concept. Now, what is meant by linear regression? Just applying the previous values. It is selecting the previous values from here to here. Whatever the part you have selected, it is just selecting that particular part. For example, I am selecting only these 4 values. For these 4 values, it is identifying the relation. And based on the relation, it is going to predict the next value. Using these 4 values, it is predicting the next value. What are the next value? So here I have selected these 5 values and I have dragged this one to the next value. It has shown the 29. Now, let us take the same values. 1, 4, 9, 16, 25. And next value, I am going to give the 36. Or here I am going to give the 29 only. Myself, I am giving the 29. Now I am selecting these 5 values and I am asking to predict the what would be the next value. Right? Now this next value is selected based on the relation of the above all the values. Now do that next value, it is selected based on the above all the values. It is identifying the relation between above all the values and it is predicting the next value, which is called as auto-regressive model. It is just applying the linear regression on the previous value, which is called as auto-regressive. Automatically, the previous values automatically considered. Automatically selecting all the previous values and applying the regression is called as auto-regressive. Right? Next. Now, for example, if I am selecting here 36. Now 6 values. Based on these 6 values, it is predicting the next value. The next value is predicted based on the 6 values, not using the 5 values. 6 values it is selecting and it is predicting the next value like this. Right? So the next value, what are the next values there? Automatically it is selecting already the 6 values and it is predicting the next one. So like this, it is going to select the previous values and it is applying the regression. This is called as auto-regressive model. In the Excel, by default, we are having the auto-regressive. The second one is there, one more, called as moving averages. Moving averages are nothing but the previous records. What are the previous records are there? Average value you are going to consider. The average value of the previous record is the estimated value for example, now in Amirpet, last 7 days, temperatures was measured at 8 p.m. Exactly at 8 p.m. They have measured the temperature in the Amirpet in one particular building. What is the temperature? The temperature is 22. On one day, it is 22. That is, day is on 26th January. It is 22 degrees. On 27th January, it is 24 degrees. On 28th January, it is 23.5. 28th January, it is 24. 29th January, it is 22. 30th January, it is 29. 31st January, it is 28. 1st February, it is 27. 2nd February, 26. 3rd February, 28. Now, on 4th February, what is the expected value? Means you are going to consider the average of this one. Simply, it is average of this one. It is called as moving average prediction. Just observing the previous values and you are considering that one is called as your moving averages. For this particular date, for example, I want to predict every day's temperature based on the moving average of 5. Now, this is the original temperature. My predicted temperature is based on the previous 5 records. So I'm going to take the average of these 5 records and I'm going to predict the temperature on this date. The average of these 5 is 23.8, assume. Now I'm predicting this value. This is the actual value and this is the predicted value. And you are going to calculate the error. And based on the error, you are going to calculate the mean square error and RMSE. This is the predicted value. How you have predicted this value? Just you have observed the previous 5 records and you have taken the average and that is your prediction. For this date, on 31st, what is the predicted value? Is the last 5 records average. That average of the last 5 records is 27. Now for this date, what is the average? Last 5 records average. You are predicting based on your previous records average value, which is called as moving averages. MA of 10, you are saying, you are explaining, okay. MA of 5, you have explained, okay. Fine, sir. But the question is, which number you have to select? Question is that one, right? Which number? Previous 10 records are, previous 5 records are, previous 3 records are, 2 records are, 1 record are, which one? That we are going to see, that we are going to get based on the PF. And so here we are having AR model. The first one is called as AR model, autoregressive, MA model. Combination of these two is called as ARMA model. And finally, we are having ARIMA model. ARIMA model means autoregressive integrated. Integrated means combined with a proper weighted. It is going to give the same weightage for both of them. 50% autoregressive, 50% moving average. But here, it is not going to give the same weightages. It is going to give the different weightages. For autoregressive, different weightage. For moving average, different weightage, which is called as ARIMA model. Right? Now, first one is autoregressive. Autoregressive means regression model only. Just your regression model only. Moving average means just you are considering the previous records. Here, the moving average of 3 records I am considering. 3 records moving average. 3 records moving average. Every 3 records I am going to consider. Right? Next one is ARMA model. ARMA model means combination of that one and combination of this one. And ARIMA. Here, how we are going to select the autoregressive number and similarly for moving average number. Autoregressive means how many previous values I have to regress. For moving average, how many previous values I have to regress. That how we can identify means we are having 3. One is called as P, D, Q. 3 are there. One is called as P, D, Q. P value is AR value. Your P value is nothing but your AR value. How much value of AR you have to select. D value is how much percentage of integration you have to do. Q value is your MA value. Your ARIMA model consists of PDQ. ARIMA model consists of PDQ. AR goes with P, MA goes with Q, and I goes with D. Okay, ARIMA model consists of 3 values PDQ. Now, how these P, D, Q values are calculated? This is the question. How these PDQ values are calculated means that you are going to select these values, PDQ values. PDQ values are selected by using PACF and ACF plots. PACF plot and ACF plot. By using these two, we are going to identify the P value, D value, and Q value. PACF plot and ACF plot. Now, what is meant by PACF and ACF? ACF plot means nothing but autocorrelation. A means autocorrelation function. ACF means autocorrelation function plot. PACF means partial autocorrelation. Right? We are having with respect to ACF and PACF. Everything is there in the PPT. Okay. So where using the ACF plot, we are going to get the MA value, and using the PACF plot, we are going to get P value. From PACF, you will get the P value. From ACF, you will get the Q value. D is nothing but integration. Integration is nothing but how much shift you have used for stationarity, right? That number is your D. Whatever the number you have used for your shifter, that number is the D. Is that clear? Now, just observe this one. For this data set, I am having a data set. First, I have converted stationarity. How I have converted stationarity means by taking the shift of 2. Shift of 2 means my D value is equal to 2. Fix. It is not going to change. Now, we are going to apply the PACF and ACF plot. So here I am going to apply the PACF and ACF plots. And using the PACF and ACF plot, from ACF, how you can estimate the plot means this is the value. Okay. How much amount of P value you have to consider? Which line crosses this graph? That is the P value. So here, if you observe this one, first one is 0. 0 means you are not considering the autocorrelation, means only M value, MA, that is called as MA model. Now here you are considering this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now first one, value 1 has crossed this line. So you can consider the Q value is equal to 1. From ACF plot, you are going to calculate the Q value. And this value has crossed here 1. So Q is equal to 1. So you have to consider the moving average of 1. Average of previous record you have to take. Only one moving average you have to select. Next, how much of auto regress you have to apply means from PACF. From the PACF, you are going to get the P value. Okay, sorry. From PACF, you are going to get the P value. The P value you are going to get as here also 1. Right? Which is nothing but AR of 1. So now AR of 1 plus D, that is nothing but P is equal to 1. P is equal to 1, which you have got identified from the PACF model. D of 2, you are going to consider the D of 2, which you have identified for stationarity, you have applied the shift of 2. Q is nothing but, whatever the Q is nothing but, here you have got the Q value is equal to 1 using your ACF value, which is nothing but moving average of 1. By combining this one, we are going to create the ARIMA model. Now, just I am going to take the ARIMA model. So from ACF curve, the optimal value of Q is 1. From PACF, the optimal value of P is 1. Now I am going to select this one. From statsmodel.tsa.arima model, I am going to import the ARIMA. And in this ARIMA, I am going to give the data, whatever the data I have taken. This is my data. After applying the shift, which is the stationary data, that data. The data which is stationary, that only you have to pass into the ARIMA, not original data. Don't send the original data. If you give the original data, it will give the worst answers. Right? So here, 1, 2, 1. So I'm going to take 1, 2, 1, and I'm applying the ARIMA model. After applying the ARIMA model, now I'm going to fit. And if you observe here, the blue line, whatever the blue line is there, the blue line and is the original data. Original data is your blue line. So here, whatever the blue line you are having, this is your original data. This entire blue line is your original data. And here the red line, whatever the red lines you are observing, that is predicted values by the ARIMA. right? If you want to calculate the accuracy, train accuracy, test accuracy, what I'm going to do is I'm going to split the data into 80% and 20% for training and 20% for the testing. Now, I'm going to use this one and I'm going to predict. And I'm going to predict on the train data. And I'm going to calculate the train accuracy and test accuracy values. Here, if you observe, you are going to get very low accuracy values when compared to it. Why? The reason because here in this, not only trend is there, seasonality also is there. For the original data, there is a seasonality also. In the original data, whatever you are having, in your original data, there is a seasonality also. Not only with trend, seasonality. Trend you have compromised by using the shift. You have done the differencing and you have brought to the stationarity. But whereas with respect to coming to this one, whatever we are having the seasonality, whenever the data is having the seasonality, we have to go with the Sari Max model, where S stands for Sari. S stands for seasonal. When there is a seasonality, add the S also. Now this model is consist of P, D, Q along with the S also. Along with your S. S value is nothing but seasonality. After a certain time, it is getting repeated. After when it is going to getting repeated, every 12 months once it is getting repeated. In the Flipkart Big Billion Days says, every 12 months after we will get the Big Billion Days says. Whatever the peakness you are observing in the Flipkart says, every 12 months once we will observe that one. Okay. The season is going to repeat every 12 months once. So here I am going to take the seasonality of 12. Just I am applying the seasonality of 12. And now I am applying the Sarima model. And now if you see the accuracy, I am getting with respect to very good accuracy when compared to the previous one. Right? The fitted values, what are the fitted values we are having? This is the fitted values. And here also you are having the fitted values. What are the fitted values you are having? Right? Just I'm going to upload this code. Whatever the code is there, the entire code I'm going to upload, and along with the data set. Code, data set, and PPT. 3 of them I'm going to upload. Just practice, just understand. And if you are having still any doubts, we'll discuss on the Monday's class. If it is clear, miss, we'll move on to the deep learning. The same time series data we'll apply using the deep learning by RNN or LSTM. Right? Is that clear, guys? Just please go through the steps. Once before moving to this one, just think of first regressive. What is meant by linear regression? Just go through the linear regression once again. And after linear regression, just come in the sequential order. First, what is meant by time series? And in the time series, if it is stationary means what happens? If it is not stationary means what happens? How to convert? After converting, how to apply the ARIMA model? Here, you will get a question that, sir, why you have selected the log, np.log, while converting to stationarity, why you have converted to log? First, I tried without applying the log, without transforming the data, directly I have applied on the original data by applying the shift. But I'm not getting that stationarity. I have tried all of them. Now, this is one more option. By applying the transformation, and after applying the transformation, again, you are trying with respect to the differentiation is one option. If, for example, here also I'm not able to get, I will try with the np.exponential. If np.exponential also I'm not getting, np.square root. For which one transformations I'm getting the stationarity of the data, that data I'm going to consider. For converting the station, for example, we are having the skewness is there. For the skewness, how you are going to convert the skewness? By applying different things. First, you are try with the log or nth power or nth root like that. First root, square root, cube root, fourth root, fifth root, sixth root. You are going to increase the root. And finally, you are going to convert the left skewed distribution to normal distribution. Similarly, I am also trying with the different options. This is one of the option only. This is not compulsory. This is one of the option where I can convert the given data to stationary. Is that clear, guys? Right? And now in the PSEF graph, whatever the PSEF graph you have observed, in this, whatever the first one, it has crossed that line. This is the first one. And after this one, third one, you should not consider 2. Q value you should not consider 2 because this is inside. So this is 3, 4. Again, 5 you should not consider, 6 you should not consider, 7 you should not consider, 8. So first you have to start with respect to 1, and if you are getting the better results, hyperparameter tuning, which is nothing but hyperparameter tuning. You have to tune first with this value. If not this value means you have to try with this value. Different options. Now I'm going to share you the data set, right? Now after sharing you the data set, first without applying the log, just you apply the differencing shift of 2 and check whether the data is stationary or not. Shift of 3, data is stationary or not. Shift of 4, data is stationary or not. Check with that. Similarly, log transformation apply and check. And once the data is stationary, now you try with the different PDQ values. D is fixed. D is not going to change. Different P and Q values you are going to try. Hyperparameter tuning you are going to apply, and you are going to try first with respect to 1, and after that 3, and after that 4. And try for which one you are getting the better accuracy. Identify with respect to that best value. And using that best value, we are going to predict the future data.